Going
Hello,
well.
everyone.
With a hat on.
I think we're live. If you guys, if the audience can see me, please put in any comment. Just say hi. Tell us how excited you are for this
We
workshop.
look live.
If you guys, if the audience can see me, please put in any comment. Just say hi. Tell us how excited you are for this workshop. Dave, I think you might need to mute your YouTube link, I believe. I hear a little bit of an echo on my end.
Mute. There we go.
All right. Thanks, Tech Yuan and Haibara and Muhammad Tayyip. Nice to see everyone's excited. So before we start the session itself, I'll do a very quick introduction about this session. So this is week 5 and day 2 of the Malaysia Blockchain Month. Week 5 will be focusing on blockchain development. And today, the focus is on Ethereum development. So this morning, for those who joined the MBM, you had a bootcamp with Blocklime. Right now at 2:30, the session is about sort of a smart contract introduction, especially with using Solidity on Ethereum. Later on, we will also have 2 other sessions for the rest of today. And for this session, our speaker is Dave Appleton. For those of you who've been in the local blockchain space, you might know him. He's been involved with a lot of different projects out there. I think too many for me to list. But in recent times, especially Ether cards and Minty Art, 2 popular NFT projects slash platforms. If you haven't explored them, you can try check them out. And Dave has been a long time sort of well-known developer and teacher on programming for everyone within the local space. So let me go to the next slide. So a quick introduction for those who are just joining MBM today. Why we're doing this Malaysia Blockchain Month is to sort of do more education and therefore help improve adoption of blockchain technology. It's not just about buying and selling and buying when the price is low and selling when the price is high, or vice versa. We want people to understand the potential of the technology and even the current uses of the technology. Especially with regards to things like self-custodying your wallets. And with increased knowledge and maturity in the space, we can help to prevent or sort of remove scams and make Malaysia a better place for building this technology. So a quick recap of what's up for this week. Yesterday, we had an initial bootcamp with Harith from Blocklime and Simon from Hive Malaysia. This morning, we continued Harith's bootcamp. Right now is Solidity. Afterwards at 4 p.m., we will have Nicholas from Etherscan who will be sharing how to use Etherscan APIs. And we'll also have actually a member of ETHKL, Simon, who will be sharing how to programmatically interact with smart contracts. Tomorrow, we will have a focus on Binance Smart Chain with a bootcamp at 2:30 p.m. and also similarly how to use a BSC scan API. On Thursday, we'll explore the Hiko chain and the Quorum chain. And on Friday, we'll be exploring the Ant chain and the Tezos blockchain. So without further ado, let me allow Dave to share his screen. And Dave, I'm gonna unmute you. Actually, no, you have to unmute yourself quick. I see someone saying bloody week. Well, it's hopefully a nice kind of bloody.
There. Does that work?
All right. Yes, sir.
Let's
so
rock and
I'll
roll.
let you take the stage. And for the audience, if you have any questions, feel free to put it in the chat, whether you're on YouTube or Facebook. And at the end of the session, we will collect the questions and get Dave to answer them one by one. All right, take it away, Dave.
Let's rock and roll. Okay. Good afternoon, good evening, good morning, depending upon what time you woke up. Hi, yes. Right. If you see me looking that way, it's because I've got another monitor over there and I'm being incredibly vain and looking at myself. Ignore it. Right. So here we are. Smart contracts workshop. This will consist of like two things. The first bit is like my quick introduction, which may or may not be quick. And the second bit is going to be live coding, because that's what I do, right? I'm afraid I never prepare coding examples these days because it's a lot more fun if we can react to things. So let us get started. Right, we're talking about blockchain. We're talking about the Ethereum blockchain. So I have been coding on the Ethereum blockchain for like about 5 years now. So I'm going to try and explain to you what smart contracts are, what makes them special, and hopefully some of you will get excited and want to get involved in blockchain projects. I assume that many of you are coders, and so hopefully you'll follow along and say, yeah, I could do that. Hopefully somewhere along the way, I will also teach you a degree of caution, because of the nature of blockchain. Okay. So here we go. Oh, by the way, the little guy in the bottom right-hand corner is because I'm reusing a template I used for GopherCon India when I was talking about Ethereum there. Anyway, okay, a little bit about me, because I'm like that. The blockchain in 5 minutes, which will take anything between 5 and 20 minutes. And then smart contracts, and we'll probably skip the last one because the whole week is really about that. Week, month, something like that. Anyway, okay. So me. Okay. Yeah, I've been living out here. It says 38 years. It's a lie. I've been here for 39 years now. I started programming in 1968, which was quite a few weeks ago. I spent much of the time out here working in technical and scientific systems, designing them from the ground up, and I started doing blockchain work in 2014. I have been, and I'm still associated with Hello Gold for for the last few years. Main activities now are Ether cards, Minty Art, both of which are different kinds of NFT platforms, and Vesto, which is a DeFi platform. And on top of that, I'm a blockchain consultant to other people who need my services. Right, that's me. So let's try the blockchain in 5 minutes. You've had probably 2 or 3 weeks of this already, but this is my take on it. What is a blockchain? I'm assuming you're technical. If you're not technical, let it all go whoosh. But there again, if you're not technical, I'm not quite sure why you're here for a programming session. I'm also assuming I'm getting notifications popping up. That's tough. Right, what is a blockchain? It's a load of signed transactions put into signed blocks, which added into a chain or a long list by signed links. I'm reading this. It's distributed basically it's distributed over a decentralized network, something like a BitTorrent network all over the world, in a way so that every single node on that network agrees that this is the current state of the ledger of the system. And this is called consensus. Oh, that was pretty fast. That was a good 5 minutes, wasn't it? Now let's go. What am I talking about? What's a transaction? looking at something is not a transaction. A transaction is anything that can change the state of something. It can be a transfer of value. It can be a transfer of data. So if I can send an envelope to Alice with 100 ringgit in it saying, "Happy birthday, Alice, buy yourself something nice." Right? This contains data, the message, it contains value. And at the end, when this has been sent and received, Alice has got 100 ringgit more than she started with, and hopefully a smile on her face. And I have got 100 ringgit less, but I probably feel good about myself as well. Right? So this is a transaction. Right? And at this current state of my life, my current bank balance, my current everything is the sum of every single transaction leading up to the present moment. Right? It is not possible for me to have 1,000,000 ringgit unless the sum of all the ins and outs ends up with a positive 1 million at the end of it. Of course, that would be very nice. Anyway, right. So this is the first thing. That is a transaction. Transactions are very easy. And so the next thing is, okay, I just throw in the odd strange statement. This is a statement by one of the famous mathematicians, John von Neumann, which I'm going to use in the next slide to describe what a digital signature is. I have written the same sentence twice. And if you look at them very, very carefully, you will notice the first one has a comma after young man. The second one has a full stop. If I use a mathematical technique called hashing on those two, I get two completely different numbers. So the first part of taking a digital signature is to take the message and to make a hash of it, and then we use public key encryption to sign it to prove that it was for me, which makes it unforgeable. Public key encryption, I'm gonna kind of jump over this a bit, but by encrypting it with a private key, you can, with the message, you can derive who, with the message and the signature, you can prove that I was the person who signed it. Right? And this is, I can make this, what's the word? Make this public at the end of it. It's, if you're interested. So the whole idea of this is if I put a digital signature on something, you can prove two things. You can prove that it has not been modified, and you can prove that it was from me. Right, so now I have a transaction, I have a signature of the transaction, which proves that that transaction was indeed from me. So the transaction from Dave to Alice really originated from Dave, not from Harith. And we stick them into blocks. Now, what's a block? A block is basically just a collection of these transactions, each with their signature, with a link to the previous block, and this whole block is also signed. Now, obviously, if this block points to the previous block, which points to the previous block, and it's all signed, then if my block is correct, then all the previous blocks have to be correct. And this is the bit I'm going to skip way over because there are many different methods of consensus. But the core of it is we have a mechanism which says that no one person makes all the decisions, unless you're using EOS or one of those pseudo blockchains. But generally, No one node makes all the decisions. Any particular node can verify, and due to a particular mechanism which would change from blockchain to blockchain, it becomes virtually impossible for anyone to modify the past records in the chain. Now, generally that is made virtually impossible economically, either through proof of work, which is what Ethereum's running on at the moment, or Bitcoin's running on at the moment, or through the fact that periodically a large number of nodes put a stamp of approval on it, which is like in the proof of stake mechanisms. Okay, so now with that, we have a blockchain, which is kind of amazing. And since this is Malaysian Blockchain Week, let's get on to Malaysian Pride, which is, if we have a look at Etherscan on the front page, this is a year old or something, so it might have changed since then, but they show you the blocks that have been mined, and they show you the transactions in the blocks. So you can see it at the level I have been talking about. And we dig down from that, we can look at the transactions. We have the hash of the transaction, we have who it was from, who it was to, and the value, if there was indeed value in that transaction. Right? So one of the first things I loved about Ethereum was the Etherscan is based in Malaysia. And Etherscan is effectively the Google of the Ethereum blockchain, and now quite a few other blockchains as well. Okay, so that's blockchain. But now let's get to the what Ethereum is all about. What makes Ethereum special? So, okay, remember we had this thing, from Dave to Alice, and I'm sending her 100 ringgit. But I also had a message. And the message said, "Happy birthday, Alice, get yourself something nice." Now, that's actually an instruction. I mean, it's got a greeting, but it's got an instruction as well. Get yourself something nice, right? Now, that data field could contain more instructions. It can contain 50 instructions, 100 instructions. And any time that you follow 100 instructions, possibly with, if this is true, do that. If it's not true, do that. Now you're starting to have a program. So the really clever thing that Ethereum brought in was the ability to embed a program. But they went one step further. So the first step was create your program and put it in the data field. But then that would only be in the transaction. So the second, far more clever step was have a special kind of transaction that will pin this code in the blockchain so that anybody can interact with it. So now you're taking a program, a very small program, a smart contract, which is what we call it, and you're just dropping it on an address in the blockchain. And this program is going to be the same on every single node in the blockchain. So all of the people running nodes are verifying the state of the program. You have a shared program and so here we go. We have an address. We have a whole load of code. It has data storage as needed, right? So it has an address. You can tell people about the address. And how do you interact with it? Well, because it's got an address, I can send a transaction to that address. And if I format my transaction correctly, I can interact with that code. I can specify what function I want to execute, what data I want it to execute with, and at the end of the execution, it will update the state of that contract. So interacting with it, well, we've mentioned talking to it and making things change. We can read from it in two different ways. The first one is we can have functions that allow us to retrieve data from it. And the second thing we can do is we can put log events so that we can read the state of the contract. So the only ways you interact with a smart contract is by sending a transaction to it, a blockchain transaction, or reading from it either through events or through read-only functions. Now, this means, of course, that unless you have special provisions for it, it can't interact with your company finances. It can't get your bank balance. It can't do anything in the real world. But you can build mechanisms to create a transaction and push that information in. So why do we consider this important? Up until Ethereum came along, anytime you wanted to interact with anybody, a bank or anybody on a financial system, you talk to their system, and the moment you're talking to their system, you have to trust them. So your bank sends you a bank statement every month, and you either have to do parallel computations, so like if you've got a housing loan, there's no way these days you can understand how the interest rates are calculated, right? So you have to trust them. You have to trust that everything in their system works. With a smart contract, because the code is public, you basically because the code is public, you can verify the code does exactly what it's supposed to do. Or if you're a layperson, you can hire an expert to verify it. Now, this can be used as part of two companies working together, so they can have their proprietary systems working with a smart contract in the middle, where the smart contract proves the transactions between one party and another. And this is used by banks. They are now using the Ethereum blockchain as what they call a settlement layer. Or you can have everything in smart contracts. Okay, I'm going to skip that. So we're going to be doing a bit of coding in a minute. So let's have some important things to remember. I already said that what you put on the blockchain, it's agreed by everybody, and it's virtually impossible to go back and change it. So once you put smart contract code out there, it is immutable. It cannot be changed. The code itself cannot be changed. The state of it can be changed, but the code cannot be changed. This is very important, because if your code starts doing something you don't want it to do, unless you've built in a mechanism, it will continue to do what you don't want it to do. Smart contracts are transparent. Now, by that, I mean that ideally the code behind it will be revealed, and you can verify that what is on the blockchain is the code used to create it. so that you can see what you are interacting with. They cost money to deploy. I did not spell deploy correctly, but they cost money to deploy and interact with. So if I want to write a smart contract and put it on the blockchain, it costs money. This is important. And actually the cost is a very important part of it, because that's like a disincentive for people to spam the system. And a mistake can cost a lot of money. And there have been, throughout the last 5 years, numerous cases of mistakes, either unintentional mistakes or mistakes deliberately inserted by somebody, which cost people a lot of money. The most recent one was the MISO auction, where the programmer who launched the thing put their own wallet address as the receiver of the funds rather than the intended wallet address. And something like about 800, just over 800 Ether went to the wrong address, which was recovered, but it took a lot of wayang to get it back. Okay, so there we go. That's my 5-minute introduction, which took about 20 minutes as predicted. So let's do some coding, and it will be live coding, and it will be unless somebody puts "I want to see this" in the comments in the next 20 seconds, it's going to be what the hell I want to do on the spur of the moment. So firstly, we have to select a development environment. I'm going, because I like to stay safe, most of the time I use the Open Zeppelin libraries as the core of my contracts, because they're like community audited. We will define a problem and we will build it. Okay, so your development environment. The first thing is we need what we call an IDE, an integrated development environment. How wonderful. I hope you can't hear too much of that. I have someone cutting the grass outside. My apologies. Development environment is a file editor, file management, and it will include a compiler, testing environment, and a few other things. Right, and deployment tools. So the first thing that I like to use for this, I've been using it now since middle of 2016, is Visual Studio Code. Other people prefer other tools, but so Visual Studio Code. Hardhat is the environment that I tend to use most these days, and I also steal a lot of code from my previous projects, mainly because I've already written it. Why should I write it again? So let's get. So this is Visual Studio Code. Before we get started, it has got a section at the top to integrate with your version control system. This is usually Git. This is so that you don't have to keep multiple copies of the file, absolutely latest copy, even later copy, and so on. We have the file and directory structure down here. We have the code here, and we have a terminal at the bottom, which I can use to interact with it. There. Is everybody happy so far? Somebody can say hello in the comments if you like. If not, let's rock it.
Dave, we have one comment from anonymous Facebook user asking if you can create a new token.
if I can create a new token, yes, I can. Most
Yeah.
definitely. So I hope you can see this. This is about as big as I can make my screen to keep my development environment, that's a new word, environment usable. This is my standard initialization script that I run. Normally I will run it. I normally do the first couple of lines by hand, and then I run the rest, the script. So let's just do this. This gets everything set up. So the first thing is I initialize Hardhat, which, if I'm lucky, it will work. Do this. And it's going to run 3 times slower for the very simple reason that I'm sharing my screen, isn't it? This creates an empty file called hardhat config. This one contains the absolute bare minimum I need for using the system, but I don't want it. I'm going to just rename it because I'm going to copy some stuff, right? Okay, I'm going to do copy. I'm going to run these first just to copy the files I really do want. I'm copying these from another project because, as I said, it makes my life so much easier when I copy pre-configured files. I'll take those out of my configuration. Right. The next thing is I will make sure that I'm using the right version of Node.js, and 12 is good for this. Oh, isn't life slow? And because I already copied the new one. Now the reason I copying stuff across is because eventually my Hardhat configuration file ends up a lot more complicated, and I just can't be bothered to rebuild it. Right, and now I will basically run all of this, and I'll try and explain to you what we're doing when it's running. Start. Okay. So the first thing that I'm doing here is I'm installing the latest version of Hardhat in here. Then I will be loading some of the essential files. Ethers is the JavaScript libraries which allow me to do a lot of the testing and deployment. It interacts with the smart contracts. I believe you got a session on interacting with smart contracts later. Ethers is probably, I'm not sure whether it's the most popular yet, but it's certainly the most advanced. I'm installing a module that allows me to verify smart contracts on Etherscan, because generally every time I deploy a smart contract, I want it verified on the blockchain so people can see my source code. Open Zeppelin, we talked about Open Zeppelin. Open Zeppelin is is a whole library of smart contracts. It allows me to deploy, for example, an ERC20 token, which is a fungible token, in a few minutes. Of course, the way I write it, I do a lot of customization for the specific use cases. So I just use them as the basis I work on. Test helpers, I don't use the last two very often, but I put them in just in case. Right, we have to wait for this to load. While we're doing that, we will create a folder in here for the contracts. This is where my system slows down a little bit. And at this point, right, someone wants to, let me see, a token. Did they say what kind of token they want? An NFT or an ERC20?
I think we can probably just do ERC20.
Right. ERC20. Okay. So what should we call this? Malaysian BW coin dots. How about that? Actually, I could do what I did last time and call it Harith coin dot sol. Okay. While this lot's loading, let's just have a look at the anatomy of the smart contract. So the first thing we're going to do is we're going to be talking to the compiler. We need to tell the compiler what version of Solidity we want to use. So we do that with a pragma Solidity. Now the latest version of it is 0.8 point something. I always say anything above 0.8.0. The compiler I've got in my configuration file is 0.8.2. I haven't changed it with the later versions because I'm lazy. And then we have, if we want to be minimalistic, the next thing we just need is contract. We need to give it a name. And what do we call it? Malaysian Blockchain Week coin. Right, we're going to start with this. And this would compile. It might complain saying there's nothing inside it, but it should compile. Now there are a number of things that we need in this for it to be useful in any way at all. We need data. We need what we call state data, which is when I send a transaction to it, that some of that information will be stored so it's still valid the next time somebody interacts with it. Some of that information may just be temporary. So I can have state data here. We can have functions which get executed, right? Functions that change the state of it. We can have functions that return the value of it. The most important thing is when I load it on the very first time, just so that I can set it up exactly as I want it to be. In other words, I deploy it, you can't start doing things immediately. I have a constructor. And this constructor can do whatever we want it to do. So we'd have a constructor. This thing is run first. This is run once at the start, right? And the next thing that we do is we will have functions that do something. Function again. Do something. As soon as this thing finishes, I'm going to start doing something a little bit more interesting. Right? Now, these functions can be publicly available. So I could say public. I can put like public in there. That means anybody can execute it. Or I can make it internal or private so that only other functions in my contract can execute it. We're still going. Okay. But if I had to build every contract from scratch, it would be incredibly painful. And these days, nobody builds anything from scratch, right? You always use like public libraries and so on. So normally, in this case, what I would do is I would have an import. So if you want an ERC20, we put import at ERC20 / ERC20.sol. I put this in, and you can see down at the bottom, it's still installing it. But if I do this, it will bring in for me a complete framework for an ERC20 contract. And this is where you pass on a lot of the work to somebody else. Now, you may think that, yeah, somebody's telling me, yes, it's Malaysian blockchain month, isn't it? Not Malaysian blockchain week. Sorry, guys. I'm English and stupid. Okay. Now, I don't just use the Open Zeppelin contract because I'm lazy, although I am. The main reason I use them is because they have been tested a lot. And if you remember, I said any code that I put on the blockchain, once it's there, it can't be changed, right? It cannot be changed. So if I make a mistake, my mistakes remain on the blockchain, and I have a load of mistakes on the blockchain. But if I do something that's important, I really want it. I want to make sure that there is as little as possible chance for things to mess up. Right? This is why I would use this. So I can say is it. If I say this is an ERC20, and I'm going to wonder what the hell I'm doing in a minute. Why is it complaining? It's going to say it should be abstract, because here I need to say ERC20 brackets. Now, an ERC20 coin has got things like a balance. It has a certain number of tokens. It has a name, it has a symbol, it has decimal places, a whole load of things. Some of this is implied. If I just create one, then it has a balance of 0, a total supply of 0. If I but I can't have a default name. So we'll call this MBM coin, and we'll MBMC. The moment I do this, it will kind of stop complaining, hopefully. So now what that means is that when it calls my constructor, it will also call the constructor of the ERC20 contract, and it gives it a name. So by doing this, I have automatically created an ERC20, right? Now, okay, I've got that. Okay. So once I deploy, if I deploy this now, I will put this on the blockchain, preferably without this function at the bottom. Let's get rid of that. If I deploy this, it will deploy an ERC20 token called MBM coin, which is essentially useless because I've created a contract with no supply, no means of creating a supply. So what I'm going to do, just to make, I can just do a mint and we'll say msg dot sender. I'm lazy, and we are going to give me the entire supply of this token, which is going to be 100. Oh God, I hate doing this. 1, 2, 3, 4, 5, 6, 100 million. Now, because this has got decimal places of 18, we'll say 100,000 ether. If I do that, I should be able to launch that. And now we will have a contract where I have got the entire supply, which is 100 million. Yep, 100 million tokens. Now, if only I could persuade you that had value, I would then be insanely rich. So let me nip back. So when I put this contract out there, this has a specific address, right? So Chan asked, is there only one instance? Yes, there is only one instance. The instance on every single machine is identical. Now, what that means is that I said it costs you money to interact with this contract. That is because if I've created it and then I want to transfer a token to someone else, every single node on the network needs to know about that transaction. Because every single node, if I sent half of my tokens to Harith, every single node on the network now needs to know that I've only got 50 million and Harith has got 50 million. So that message has to be propagated and written into the state on every single node of the network, right? So everyone has an identical copy of this smart contract and its state. Okay. Okay, so Rafik is asking, what is IERC20? Yeah, I'll kind of come to that in a bit. So I've got this now. By importing the Zeppelin ERC20 contracts, I've automatically imported all of the standard ERC20 functionality, which means the transfer functions are in there, the events are in there. This will fully comply to the ERC20 standard. I can also add other functionality for an ERC20 at the moment. There is optional functionality. The mint function is actually optional in an ERC20. I can put in, for example, a function to allow minting of more tokens. Mint, right? And now we're going to start talking about some of the other things in here. And we're going to talk about security in here as well. But I could have, right, mint brackets message dot sender comma amount. I could say, what happens if 100 million is not enough? If I want to spread it, 1 million to all my friends, and by some miracle, one day I have more than 100 friends, maybe I want to create some more. So I can create this function called mint, and I can create more tokens. And the only problem is that I've just put in a function which allows anybody to create more tokens. So maybe I also want to add another Open Zeppelin library here. Very interesting, with a space as well. Right, we will add in a library which is called Ownable. And I'm just going to add in here, comma, Ownable. Now, if I put in here now that this should be only owner, part of the Ownable code has got what's called a modifier, which means that although this code is public, if anybody tries to call it who is not the owner, which is, hey, it's me because I launched the contract. Now, if anybody tries to launch this contract, tries to call this mint function, it will fail for them. If I leave this off, suddenly anybody can create tokens. Okay, so now I can mint. I can also have say a burn function, allowing somebody to burn all of their tokens. I'm not going to bother with that. Let's just see what we can do with this at the minute. Okay, since everything has finished installing, let's see if we see what we can do here. This ain't going to work. The reason it's not going to work is I don't have everything I need yet. Sorry, let me just check what I've got in here. I need 3 things from this. Yeah, that'll do. What on earth happened there? Eek. Go. Oh, that's evil. My computer's suddenly acting very strangely. Come on. No. If I do that, it will create the last few files that I actually need, which are private key files, because that's the way I do things. Give me a moment. In my config file here, what I do is I use 3 separate private keys for different networks. For the Hardhat network, I don't need keys, but I have them for Ethereum mainnet and the test networks and so on. I have a different key for Polygon as well. Okay, I've created the keys. These are the addresses. So now I should be able to compile everything. npx hard keep up computer. Oh. Let's see if that works. Unfortunately, every time I broadcast, it kind of slows my computer down a lot. I sort of like realized my computer was getting slow, so I bought. What? Ah, this is interesting. What did I actually type? The npx hardhat compile. Let's try that again. Yeah, I bought myself a new computer, lots of memory, lots of everything, and then I started opening more and more windows, and now it's just as slow as it was before. And so when I stream, unfortunately, it's still slow. So if I wasn't streaming, this would happen really fast. It would compile my program. As it is, it's going to wait for a minute or two. What's it doing? It's catching up with me there. Okay, so here we are. It's compiling 6 files with. It's created. It has now created the file, which is pretty cool. I can see about. We can run a test on it. So what we need to do is we create a test folder. Rename to test. And this is where I'm going to be. I said here that when I do this, I almost always just copy stuff from previous projects, which is exactly what I'm going to do here. Test erc.js. And unknown to you, off on the left-hand side, I have a load of my test programs, and I'm going to copy from one. If I can persuade it to be copied, here we go. Okay, come on. Okay. You can do this. You can do this. Here we go. So in my test, I'm going to import some libraries, hopefully. Yes. Oops. And now from here, what we would do is we will, okay, the way this works is you say, describe brackets, test my ERC20 function. And all of my tests are going to go in here. And we will start with IT. I do believe this it should have function in it, shouldn't it? I do believe this stands for oh god, what does it stand for? Item test, I think. Give me 1 second. I'm just trying to scroll my other screen, which is giving me grief. Never mind. Oh, that's it. Yeah, okay. Item tests. Here we go. If I can. Oh, mouse. Thank you. Before all. You. Okay, let's try that again. Copy this, back up into there. Like I said, my system gets insanely slow when I'm streaming. I'm sorry. It's something about having like 30 numerous tabs open, numerous windows open. Async function. Here we go. Okay, so the first item test happens before everything else, right? And we need to get signers from this. So we say owner, comma, ADDR1, comma, dot, ADDRS. Okay, so I'm going to want to be able to, in running this test, I'm going to want to be able to have some like key pairs that can sign transactions. So here we're going to have wait ethers signers. This pulls those out. Then the next thing I want is, I need to remember the name of this contract. This contract was MBW coin because, as I commented before, I had this strange idea that it was a week and not a month. So now we need put the coin equals await ethers dot gets contract factory brackets quotes, paste that in, and while it looks quite complicated until this point, I can now just say, okay, the one with the capital coin is just loading the instructions on how to build one of these. But if I now say coin.deploy, it is only in my test network, but I now am deploying the contract. And if I save that, very, very hopefully I can actually run it. And knowing my luck, it's all going to go wrong, but we will Hardhat test. And we tell it we want to be on the Hardhat network. Yes. I've written a really simple test. It doesn't actually do much, except it proves that I can deploy the contract. Give it a second or two. It will compile it again if it needs to. Otherwise, it will run through this test. It will pick up a signer. Oh, there we go. Test my ERC20. Okay, a little bit slow. Right, it passed. Yay, that's amazing. Now, if I want to be able to refer to the big coin or the little coin, and I only need to refer to the little one, really, I'm just going to put it here so that I can refer to it across tests. So did I get any coins? Comma, basic function. Okay, now what I'm going to do now is I'm going to see what kind of balance I've got. And to start off with, I'm just going to print it out. Console.log. Now it's going to be little coin dot balance of, and this ain't going to quite work, but owner dot address. I need to put an await in there. Okay, we're doing asynchronous programming here because things take time. You're going to be talking to the contract. It may take a time. In fact, I also needed an await here. Now it should be good. Now let's see what happens. I run the same test, and now we'll run the second one as well, and it should tell me how many coins I have created. If I'm insanely lucky. Do it. It's not, the second one is not technically a test. It's more like an information thing, just to give me the confidence that the things are moving forward. It says it's a big number, but there are certainly some coins. Now, if I really wanted to do this properly, I should convert. What I should really do here is probably take that out, put it in and say the balance equals that, and then I would convert that in probably something like ethers dot utils dot format ether. Now, if I do that, it will probably then tell me that I have got my nice 100 million. Now, I should actually write a test that will check that I've got that. But let's see what it just shows me. Come on, baby, you can do it. Ooh. That's because there should be an S in ethers. So what we're going to do is we will run that test one more time. But while we're running it, we'll write the next test. And in the next test, what I'm actually going to do, because I'm a nice guy, and because we mentioned it before, I'm going to change the second signer to Harith. So now I can say oops. Transfer some to Harith. Right, so now you can see when it was running, it says that I have got my, hopefully, there we go, just highlight it so you can see there are 3 zeros, another 3 zeros. There's 100 million tokens that I now have. So now we can, if I want to transfer some to Harith, all I say is coin.transfer. Who am I going to send it to? I'm going to send it to Harith.address. And how much am I going to send him? Being a nice guy, I'm going to send him half of it. And I would do that by saying, again, I would use helper functions, ethers.utils.pass ether brackets 500 1 2 3 4 5 6, and we need to wait that complete. And if I do that, I can now do this. Now let's have a look and see how much each of us have got. Owner address, and then there is Harith.address. Right, so now you can see here what I've done is I transfer, hopefully when this runs, I would have transferred half of my net worth to Harith, and I will then print out my balance and then Harith's balance to show you that we both have half of that amount. if I got it right, and it didn't like it. And it's going to tell me why. Yeah, transfer amount exceeds balance. 1, 2, 3, 4. Of course, because you can only transfer 50,000. Okay, so it told me I've made a mistake. I was actually giving Harith 5 times what I actually own, which is not the smartest thing to do. Try again. It should work. Okay, how are we doing for time? I've used 40 minutes of that time. Let's see if we can get this thing deployed and verified on a test network. There we go. You can see that Harith and I have now shared our wealth equally because, of course, I owe him 50% commission for getting me this gig. Right. Let me try and see if I have any questions popping out that we can answer as we go along. Here. No. Hey, Zul. Hi, Zul. Good to see you. Right. Okay. Let me see. Okay. So let's get this thing deployed. By the way, Zul, who has just joined, was with us at Hello Gold, one of our amazing blockchain guys. Yeah, good to see you. Yes, hi. Now he's into all sorts of amazing infrastructure stuff. Yes, right. Okay, so what do I? And he's probably absolutely amazed that I'm using a JavaScript-based environment. Okay, so now this was a test script. Now we want to deploy it to a network and verify it, and it's like giving you a complete cycle. It's not a complex cycle, but it will give you a complete development cycle. So I'm going to create scripts folder. Oh, here we go. I'm lucky my deploy.js. Right. And again, although you can't see it, I'm going to do exactly what I said before. I am going to steal from my other code, which is running somewhere on the other side. Close that. And of course, I have a project on the left-hand side which doesn't have a deployment script, does it? Why not? I'm going to scream. Okay, I'm going to... Don't look too hard. This is kind of the evil stuff going on here. Let's see. Do I ever deploy front end? No, definitely not front end. Don't let Zul see my front ends. They're terrible. That's it. That's it. I should have, if I'm lucky, I've got a deployment script here. Sale. No, close contract. Give me a moment, please. Bear with me. Like I said, I always copy my code. Oh, that would be fun. We could take that one. There we go. So for this, I'm going to steal the top couple of lines, which is, I don't even need the FS, I don't think. I just need that one. And I want that down to there, down to there. Okay, I want that and that, down to, wait for it, just that line there. Now we'll shoot back to the other one, which is here. We're just starting to build this out. So this is my deployment script when it chooses to paste it. Is it going to paste it? Yes. Did I paste it twice? No. Yes, I did. Okay, here goes. So now we need to close that. Deploy stuff, and then we need a little bit at the bottom. Hey, kids, keep out. Layla, keep outside, please. Okay, go on. Okay, run away, dear. Meet Layla. She's really cute, and she's a lot older than anybody else can remember her. Okay, and then sorry, right down at the bottom of this one. Just have to get to the bottom of this screen for the last few lines that I'm going to copy. If I'm really lucky. Come on, baby. There it is. That's it. Just those few lines. And oh God, I hate. There we go. Copy that. Trust that. One more. Come on. Okay, we stick that down at the bottom. Then we can do the last. Hopefully, a few bits of code here. Just wait for it to come back to me, please. Yes, there we go. Paste that in. Right, and the first bit of this is really simple. It's kind of just like the rest, which is we need to get the signer. We need to deploy. Right, so we just say owner equals ethers dot signers, and then yes, this is it. This is pretty much the same as we had in our test window. We should just be able to steal those two lines. Come on, baby. Steal these two lines here. Yes. Come on, you can do that. Yes, you can do that. Right, here we go. Stick those lines in. Now, by the time we get to here, we have already deployed the contract, kind of. So at this point, we can say console log coin dot deploy transaction dot hash. But when we saw the Etherscan screen, you can see that each transaction has got a hash defining it. When I call this deploy function here, if it deploys, you will get a hash, and you can automatically test it on Etherscan. And let's say we're going to run on Rinkeby instead. Okay, yeah. Okay, there are a number of different test networks. The Mumbai one I was referring to is actually for the Polygon network. So that, like, this would be on Rinkeby. If I do this, it will just deploy it, and it will tell me the hash of it so I can track it on Etherscan. The only problem with that is I will end up with an unverified contract, and we wanted a verified contract. So now what we're going to do here is we're going to wait. So we say await coin dot deploy transaction dot wait. And any of this could actually die on me because that's my life. And the last thing, I'm going to try and copy it again from somewhere. The only question is where. Let me try and sneak it from. Okay, I'm going to try and steal it from the other side again. Because it's probably the only place I've got it. Okay, in here I have got somewhere down this page. It will react very slowly, but okay, this will do. Yes, I copy that line there. If my life is good, I copy that. I come across here. Oh, come on, come on, come on, come on, come on, come on. I just put this in here. Wait for my cursor to arrive. And this will deploy on Etherscan. Sorry, this will verify on Etherscan. The only thing I need to do is to wait for a moment, which I had forgotten. And this is going to be, the address is going to be coin.address. There are no Yes.
Just Harith. A quick note, Dave. We're at 3:51. You have about 10 minutes for the session.
Okay.
We can probably push back the next session a little bit, but do keep in mind we want to have some time for answering the questions.
Yes. Yes. Okay, I will do that. I'm just going to copy 2 more lines from that code, hopefully, and we can run it, and I can answer questions at the same time. And if it fails, it fails. I thought I should have it. I don't have my timing loops here. Okay, the only problem. Oh yeah, here we go. Yeah, this will do. 30 seconds. Hopefully that will do. Is copy that. Okay. Yeah. Let's just copy this across here. Yes, yes, yes. Okay, that line needs to go into here. Are you there? You're there. Yeah, okay, I can paste that. If I'm insanely lucky, this will verify my contract. 30 seconds might be a little bit. I'm going to give it a minute after it says it has. This is just to allow Etherscan to get everything logged in after the contract has been done. Now, this is not going to work. The reason it's not going to work is I'm using a private key I've never used before, but we have to try. So we're going to say mpx hardhat run scripts deploy.js. And the reason we try it once is because we have to transfer some test. And it's still not going to work because it's on the wrong network. Let's try that again. Network. Whoops. Rinkeby. Okay, so now it's going to use a specific test network, the Rinkeby test network. And if I'm insanely lucky, the first thing it's going to do is to tell me that it can't do anything, but it's going to tell me the address of the wallet that's trying what? Let's check it says Rinkeby does not exist. Now this is a pain. I've got Gurley, I've got Kovan. So let's just add Rinkeby to all of this, shall we? One, two, rename that Rinkeby. Copy this. Come on. Copy that. Put it there. Yay. it again. That should launch, or it'll fail to launch because there's no Ether in that wallet. I can't remember the wallet address. But let's have some questions. We can be doing this while there's no more coding here, so let's just see answer some questions and see what we can do.
All right.
Anybody have any questions?
I will. If anyone has any questions that you haven't asked yet, please feel free to comment in the platform that you're watching on. I will show the questions on the stream, like this one right now, and we can get Dave to answer. So One Kid Fong asks, how does a contract get verified? Which is the process that you're doing now.
Yeah. Okay. So the main thing is you have to have the source code. You have to have the correct information. Hang on. Give me 1 second. Let me just do this. Okay. Okay. So you need the source code. You need to know the compiler version. Right, because as I showed you, I'm compiling with version 0.8.2. Every different compiler version will create different versions of the code. You need to know whether it is optimized. If you put all of that information, then okay, if you put all of that information in the source code, you go to the first way you can do it is you can go to Etherscan, and if you give me 1 second here, let me just see if no, I can't do that. Okay, I probably can't do this. I can't put test ether into this address, which is a pain. Right. So the first way is if you've got the source code, you can actually upload it to Etherscan, and Etherscan will compile the contract in the back end, and it will check. You tell it like if there were any parameters in the constructor. You also inform Etherscan what those parameters are. Like most of the time it can deduce it, sometimes it can't, so you may have to tell it. Right? You do that, and then Etherscan will compile the code and check to see if the result of compiling that code with those parameters would generate exactly the same code as is on the blockchain. If it matches, then Etherscan will register that code is verified. Another way of doing it is what I was trying to do here, which is to what I was trying to do here was to do it by the contract itself. Sorry, by the program. You can do it programmatically. So Hardhat will verify for you. Put this over here. You don't really. Give me 1 second, and I will try and get it so that we can do that, and you may be able to see this. Like I say, my system is horrendously slow at the moment. Harith says I have 30 minutes. Good heavens. Okay, what do we want? We want Rinkaby, which should be yellow. Okay, let's go back to my code here. I need that address. Yeah, sorry, do we have any other questions while I'm trying to prove this?
Okay, another question from a Facebook user is, what is your opinion on Ethereum 2.0 and specifically any effects it would have on the smart contract ecosystem?
Just a small question. Okay. Yes. Interesting question. Okay, so basically the Ethereum 2.0 has got a number of stages. It's a bit like 2.01, 2.02, 2.03. The first one, of course, is proof of stake. This is, I mean, it's been running on they've been running a test net or actually a live net, but not actually doing any serious transactions for almost a year now, just to prove the whole thing is robust. So proof of stake reduces basically energy usage. So the consensus mechanism is changing, and it would be really nice to think that this would reduce the attacks on the Ethereum ecosystem, because you get all of these senators and people standing up saying, look, it's all very wasteful, right? I don't think that will happen. You move to proof of stake, you stop burning energy, they will find something else to criticize because they're afraid of Ethereum, they're afraid of blockchain, the financial side of blockchain, undermining the monetary authority of the US dollar, right? But that's the first thing. It will reduce dramatically the energy footprint of the Ethereum network. Part two, when we get to introducing the sharding, now that it will change the way smart contracts operate quite a lot when you have one smart contract talking to another. Or so I believe, but since we're not there, it's a bit hard to tell. But it will also make things a lot faster.
Quick note for Dave, because we're already past 4 p.m. And we do want to make sure we can get to the next session. May I suggest that we cover maybe one more question on this stream?
Okay.
And for the other questions, for the audience, you can ask in the ETHKL Telegram group, which I will share in the comments on both platforms. And then, then Dave, you can answer those questions afterwards, because we do have to be conscious.
I will also publish this if I fix any bugs that are in this. I'll also publish this contract, probably minus my keys. Undefined. No, obviously there's a bug somewhere. Not sure what it is. So I'm going to have to check to see what the issues are. Line 19. No idea what that is. Okay. Fair enough.
Okay. So Dave, one final question for you live on the stream, and just as a reminder, the other questions we will post inside Telegram and for Dave to answer. So one final question for you is the earlier one that Rafiq asked about interface ERC20. I want to know what is the use of ERC20.
Okay, yes, this one is actually very important. But it's used when you have one contract talking to another. So if you want a contract to call the functions of another contract, you basically need to tell it that this contract has got the capabilities of, it's like, in here, for example, in my code here, I've got like coin.transfer. Now I can have that in another contract, but I would use IERC20 to tell my compiler that coin has got these capabilities without actually bringing in all the capabilities. So in other words, it's a very light way to describe what something can do. Otherwise, you drag in all the other code and you end up deploying a lot more code, and it's very cumbersome. Does that kind of help? I hope that helps. I mean, you can also use it to say that something must have these capabilities. So if I said my contract is an IERC20, then I'm describing how my contract is going to work, and the compiler will ensure that my contract is an IERC20, that I must implement every single function in the IERC20 specification. So, in this MBW coin, I said it is an ERC20. Now that is letting Zeppelin do all the work. If I said it is an IERC20, I have to implement the transfer function, the transfer event, the transfer from function, all of the other functions. I would have to implement it, and by it will all be ensured by saying that I am an IERC20, and so the compiler will not let me compile unless every single one of those functions has been implemented. Now this is really cool. I managed to okay, I had an invalid Etherscan API key. Now there's a problem. I brought it from the wrong file. But when this was running, by the way, it did get down to not this one, the deploy function. It deployed the contract. I probably didn't do anything clever. Okay, we should be able to see this transaction on the Rinkeby network. Because I had a wrong API key, it did not deploy it. Sorry, it didn't verify it. Let's bring this back. But we can quickly see that the token was deployed on the Ethereum, on the Rinkeby network. Doesn't matter what we're looking at. We're just going to key this in. Okay, were there any more questions? If not, we can take them in the channel. This is the transaction that deployed the contract. There we go. So, and it says that I deployed 100 million tokens to the address that I deployed from. Bingo. Unfortunately, I failed on the verification, but I can always run the verification again. I will do that in a while.
All right. Anyway, thanks a lot, Dave, for sharing. As mentioned, for the other questions, please head to the ETHKL Telegram group, where Dave will answer them afterwards. We are supposed to have another session starting at 4, which is how to use Etherscan APIs. There is another link for that. If you don't have it with you yet, I will also share that in the respective comments in the respective platforms. But we'll give ourselves a couple minutes for a quick break. Join at 4:10 p.m. on those on the other link for the Etherscan APIs platform.
Mm-hmm.
Dave, any final comments from your end?
Are you buying the drinks?
We'll do it over the weekend. All right.
Okay, guys. Yes.
All right. Thanks a lot, Dave. And
right,
yeah, please follow up with Dave afterwards on Telegram. A quick note for the sponsors of Malaysia Blockchain Month, sponsors and partners. So Bitcoin Malaysia, Blocklime, TalkChain, ETHKL, Grenade, App Media, DeFi Singapore, and Imperium Universe. Thanks a lot for these partners for making this session possible. So with all that said, thank you guys, and we will see you in the other link.
Ciao.